Okay, so we have another geometry question. So P is an interior point um, of a right angled isosceles triangle. So we have a right angled isosceles triangle. P is a point inside it, and the triangle has AB as the hypotenuse. Okay, I don't know whether that is relevant or not. The perpendicular distance of P from each of the sides. So whenever you have this information, perpendicular distance of this point from each of the side, so essentially, what you should understand is, I mean, this distance that we are talking about. So there's a point. Let's try to understand why so, because I don't want to just give it to you or ask you to by heart it. So this point that we have is the perpendicular distance from each of the sides are equal. So basically, whenever this happens, you'll always have a circle that will pass like this, right? Because radius and tangent meets at 90 degrees, isn't it? So radius of the same point, that is, radius and tangent on the same point of the circle will always meet at 90 degrees. So if you know that, so this becomes very easy because now, so what I'll do is in order to begin this idea, so I'll just derive or rather generate it in a way that you don't have to remember it. Let's try and do that. So first of all, what I'm going to do is I'm going to consider the unknown bit something. So first of all, I know that this is 4 root 2 minus 1. Now check this figure here, the one I'm highlighting. This side and this side is equal. This is 90 degree. This is 90 degree. So obviously this is a square, right? Because we have a couple of 90 degree. Also, this is 90 degrees, isn't it? So this is definitely a square, right? All the angles are 90 degree and the adjacent sides are equal. So because we have this distance as this 4 into root 2 minus 1, so effectively this distance is also 4 root 2 minus 1, and this distance is also the same, right? 4 into root 2 minus 1. So this is not relevant that much. I'll just take this off. Basically, one of this we can use to figure out, because if you remember, it's not only a right angle, but it's also an isosceles right angle triangle. So the next thing that we are going to use is we are going to assume this value to be something, let's say A or something. So let's say this distance is A. Now tangents from the same point are always equal in length, right? So these are a couple of tangents to the same circle from the same point. So because this is A, this should also be A, right? Now, as it is an isosceles right angle, so here also we'll have an A because this part is same as this part, and the entire thing is equal. So this is also A, implies this is also A, right? Again, tangent from same point. So the hypotenuse that we are getting is 2A in length, and this side is A plus 4 into root 2 minus 1, right? Now, I hope you know this that for a right angled isosceles triangle, the sides are in the ratio 1 is to 1 is to root 2. If not, it's very easy to figure out. These two are equal in length. Just consider it as 1 and 1. In that case, just apply Pythagoras, you get root 2 as this side. So essentially, the hypotenuse is always root 2 the side of any other, root 2 times the any other side for an isosceles right angle triangle. So effectively, what we have is this length is equal to twice of this length, isn't it? Sorry, root 2 times of this length. So let us try to evaluate this. I'll just quickly write it on this side. I'll just take this off. So this hypotenuse, that is 2a, is root 2 times this a plus 4 into root 2 minus 1. Don't get confused with the brackets. I don't care about that. So one of the root 2's, you can take it off. So you're left with root 2 again. And just subtract this a on this side. So you get something like this is equal to 4 into root 2 minus 1. So now this entire root 2 minus 1 cancels off. And you have a is equal to 4. Now, as soon as you have this a is equal to 4, either you can evaluate the sides or the hypotenuse, whichever you prefer. I will prefer to figure out the hypotenuse because that is 8. Now, once you know the hypotenuse is 8, so each of the side has to be 8 by root 2 using the same idea again. So that is 4 root 2 as the side length. So the entire side length is 4 root 2, right? You can obviously add this to A to get the side length as well. You'll see that 4 and 4 will cancel off. You'll get the same value. So the side length is 4 root 2. We are looking for the area of the triangle. Each of the sides are 4 root 2 in length, each of the perpendicular sides, that is. So this is the area of the right angle triangle, right? So the root 2 into root 2 is 2. So you can cancel these off. So the answer is 16 here. That is what you have to input because you're looking for square centimeter again. So I hope this was understood. Remember this idea of in center and in circle when it comes to the right angle triangles and all. So this tangent idea always help. Many of you might have by hearted this. So if I have a right angle triangle with sides A, B, C, then the in radius is A plus B minus C by 2. You don't need to by heart it. It's basically from this idea itself. Rather, I would recommend if you want to remember something, just remember it in this way that let me just show this once. If I have a right angle triangle, now since this is R, and the square idea, so this is R. So this leaves A minus R here, B minus R here, and this is B minus R, and this is A minus R, right? Because of the tangent idea. So this is just the derivation. Let me just take a line here. And if this entire hypotenuse is C in length, so what you know is this plus this is the hypotenuse. If you have to remember something, just remember this. It's a logical thing to remember, and there's less chance that you forget this or mess it up. So A minus R plus B minus R is equal to C. So C being the hypotenuse, of course. So I hope this was understood. If you know this idea, you can solve this in a minute and a half or something. So ideal time should be somewhere in the range of 1.5 minutes. If you don't know this idea, this might be a little tough to solve without it. If you don't realize this point is basically from this statement because it's equidistant. Perpendicular distance is from each of ABC is this. If you don't realize that, then it might become a little difficult, or rather, might be you won't be able to solve this question at all. So that's it for this question. I hope you were able to solve this. This is one good question that might give you an edge over others. So thank you.